the notes have become a little bit muddled because I've changed the order I've done things in. So there's an exercise in the notes I gave you last week around you documenting the solution program to where you had the double coiling problem. So there's a solution to that. So last week's notes include a little bit of a step-by-step run through of how to document that program. I'm just going to show you the key points of documentation up on the board now, and then when you start you can go through that exercise, document that program, and then I would suggest from now on, and you're going to maybe make a start on your traffic light programs today, that you actually get in the habit of documenting as you go along. So up front, as I'm now going to show you, put in the names of your key inputs and outputs, timers and that, at the start if you know what they are. So in the specification for the traffic lights, it will tell you which outputs are on, which Y number and so on. Name all them up front, and then as you use new things like timers, counters and relays, name them as well as you go along. That way you keep your documentation up to date and you can understand what's going on with your program. Okay? So, making a point about program documentation, it's invaluable when it comes to fault finding. Even if you've written a complex program, even if you write it, a complex program might well be difficult to understand 6 to 12 months down the line, even if you were the person who wrote it, if the documentation is not good. For someone who wasn't involved in the writing of it, they got virtually no chance without documentation. And if you'd like me, worked on machines where I had 80 pages of a ladder program with absolutely no indication of what each element did whatsoever, or even what the ladder rung's done, you'd understand the meaning of good documentation. Still had to fault find on them, still managed to do it, but a lot more difficult than it would have been had it been properly documented to similar standards we're going to talk about today. So GX Developer allows you a number of elements to document of a ladder program, the most significant of which are Rung Statements. These are multi-line statements that allow you to explain in detail what that section or what that line of program does. So sometimes it won't require a lot of detail. In other cases it might require some additional detail, so you put multiple lines in. And I'll show you those in a minute. Comments. Full comments in 4 lines of 8 characters. So that allows you can turn them on and off on the screen, and that allows you to explain in detail the purpose of each the purpose of each program element, what that input is. Is it a push button, a switch, and what it does, and its actual function. Okay. Then what you can have, you've got your device name, that's X1, X2, X3, Y1, 2, 3, all of them. But you can also have what's called a short alias that effectively can, if you want to, replace that Y number, X number, although I wouldn't recommend that, because that's what your terminals are on your PLC, so you can actually find X1 from the terminal number if you want to put your meter on it, for instance, to see if the signal's there. But you can have this alias alongside that element number, and it's like a short 8 character, no spaces allowed, but a short way of naming the devices. So you can turn the full comments off and save screen space, but still have a small indication of what that, sometimes cryptic, but a small indication of what that element is. For example, using PB, PM, P, ON, that's push button, pump, on. So that's a push button to start the pump. For example, now I would suggest you come up with your own kind of standard. You can't have any spaces, you've only got 8 characters. In some companies they might have their own standard about the way you name elements, so that goes right through the company and you get an understandable scheme for the whole company. Just depends. But if you have a standard, and I tended to use the first 2 letters to say whether it was a push button, a limit switch, or some kind of sensor, just to give an indication of what type of switch it was that actuated that input, for instance, and then some letters to try and describe what it does in some way. Okay? So, what that looks like on the screen, and I recognise that diagram's quite small. See if I can. You can see it in your notes. That one up the top there is an example of a full element comment. Okay, so it says that switch to start the cycle, and this one, that one there is the example of the alias. It sits with the T1 on top, and I've called it on time. And this one here is an example of the rung statements. Okay, so when you hand in your documented program at the end, the standard will be that every element has a full comment. Every element has some kind of alias associated with it, and both the number and the alias are displayed like I've got on the screen, and every ladder rung will have at least one line of statement to say what it is, what it does. Okay, any of that being missing will mean you get downgraded in some way. Okay, with that? And like I say, in last week's notes, there's a kind of more detail on that. I'm just going to go through how you input each of those now on my short example program, which is effectively my program for the flashing on and off cycling light, on for 2 seconds, off for 2 seconds. So the first, what we're looking at is these three icons here for doing the, or actually two of those. The alias you can only input in this area over here. So what we need to do is I need to put in a name and alias for X2, and for T2, T1 and Y2. So if I double click comments over there, now always defaults the input devices coming up first, and this is something like switch on, so you can I'll put that in, switch system on. You can actually put the full comment in on this screen if you want to. Then in the alias, I always like to use capitals, but you don't have to. Switch on, yeah, SW on. You can only do the alias in this screen, like I said. So that's the input. Now, this drop-down box here, until you go to outputs, timers or counters, for some reason they don't come up in the list. It's another foible of this software. So to put my output in, I need to type in Y0 in there, and then it displays them. And after I've done that, they come up in the choosable list. Okay? So I'm using on my program Y2, I think, is flashing lamp, yeah. FL lamp or something like that. So having done that, I'm also using T, so I need to put T0 in there, and then I'm using T1, I think that's on time. Off time. like so. Okay, and on other programs there might be many more of those to do. To go back to my program, I double click on main there. Right, nothing's changed yet. The first thing you need to do to get the aliases to display is go to the View menu and say I want the alias displayed. Look what's happened. The letter and number has been replaced by the alias. That doesn't help us if we want to know the terminal number that switch is associated with to test if we've got 24 volts on it or not. So what we also need to do is go to the View menu and say alias format arrange with device and display. That way we get both. So we've now got X2, so we know that input 2 is the on switch. We've got all the information we need.
How did you do that last bit, sorry?
You go to the View menu. I seen the notes from last week as well anyway. Alias format display and select arrange with, because it says the default is to replace the device name with the alias. My recommendation is that you display both. Okay? My standard, in fact, not my recommendation, my standard is that you display both. So that's how you put the aliases in and how you get them up on the screen. You can also enter the full comments in that screen. However, if we go again to the View menu and turn the comments on, notice how turning the comments on takes up more room on the screen, because we've got to add those 4 lines of comments in green here. Also, if we focus on that one, it split the word system on there because of the 4 lines of 8 characters format of it. If I go into this mode, edit comments, I can actually edit those on this screen, and you get a useful little indication here of how that's going to be formatted. So if I go between there and put a space in, and go in there and put a space in, I can format that so it looks nice. So probably easier to put the full comments in on the ladder screen and get them looking nice. Yeah, notice that you only have to do it once. All the versions of it update as you do it once. Yeah, the others are all reasonable. Flash lamp on time and off time are all okay. Yeah. So that's how you do the alias and deal with the full comments. Okay. Quite often want to turn the comments off because they take up too much screen. I want to be able to see more information, so leave them off. Statements we do like this. So you turn it into statement write mode. Double click at the beginning of the line. Timer 1 is the on time for the lamp. Some kind of statement like that. I usually tend not to write mine in capitals for quickness. Do that here. Okay. We can also do that and write this is a second line if we need to, so you can put multiple lines in. Yeah. Double click here. Yep. So you can have as many lines as you like between each rung, so that you can describe as best you can how your program works. And I'm not saying chapter and verse, but if you can indicate what some particular elements do that might not be obvious to somebody reading the program would be good. That where things get a little bit more technical about how it works, just try and indicate that with comments. And it's a reminder for you as well, if you was going back to it 5 or 6 months down the line as to what you were doing, why you put that particular piece of code in to get around or to provide this certain functionality. Okay. Again, you notice when you do line statements, it grays the program out, and you need to convert with F4 to get rid of that grey. Doesn't do that for the comments, but it does for the statements. And you can actually transfer them with your program. That way, anyone who downloads your program from the PLC to their laptop for monitoring purposes can get the Rung statements with it as well. I'm not suggesting that you, in this case, upload them, but you can do if you want to. So that's a quick run through of how you do the documentation. And then what I'd like you to do is do the exercise in the notes that you had last week, which are the ones that got structure of PLC on the front of them. And I'll tell you which page it is. Starts on page 29, and it's got a step-by-step indication of how you do each of the things that I've just shown you in more detail. So I would suggest that this week you start by loading up your solution to the double coiling program and document that by going through that exercise. Are you all reasonably happy with that as far as a run through documentation? Of course, I'm here to help if you get stuck. Going back to the notes from this week. Again, you've got some of this in last week's notes as well, because again I couldn't make up my mind when I was going to do what. I've stuck it on here so we can just have a quick run through. Your traffic lights, pedestrian crossing, boxes like this. You've got your red, amber and green lights for your traffic, and over here you got don't walk, walk and wait, and a push button to say that you want to cross. Okay, I'm going to give you, although I think I might have put it in one set of notes, I'm going to give you a separate handout when you're ready to do the pedestrian crossing. It's got all the inputs and outputs on the front, what thing is connected to what terminal, and it's got a full description of the specification for the program on the back. Yeah, so I'll give you that separately when you're ready to start that. Okay, but I'm going to go through, and again, in the previous week's notes, these step-by-step how to start this off are also in there for you to follow. Going to just go through the first little bit. Okay, so what you've got with your thing is an indication of what your inputs and outputs are. So it tells you that the push button is connected to X0. It tells you that the green light is Y0, the amber light is Y1, the red light is Y2, and so on. So you can immediately, as soon as you set that program up, you can go and name all those elements and document them before you even write a line of code. Yeah? Moving on from that, when you write any program, it is recommended you have a strategy for writing a program is to work through the specification of operation in a step-by-step fashion. So write the code for each part and test it to see that it works up to that point, and then move on to the next bit, and then the next bit, and then the next bit. Okay? Use the monitoring function in GX Developer to monitor the operation, so you should have designed something that you believe is going to work. Not a guess. You think, I've done it this way, I think that'll do what I want it to do. Program it, test it. Does it do that? If it doesn't, modify it until it does. Get that bit working, then move on. Don't try and write a program for the whole thing in one go, because you'll end up with lots of bugs to solve rather than just one. If your program worked up to that point previous and then you do one new line and it now doesn't work, there's a problem with what you've done and you know where to look. It might mean you need to make a change earlier in your program to get the two parts to work together again, but you've only got a small problem to solve. You write 10, 20 lines of code and then try and debug all of it, you've got several problems to solve all in one go. It's not the only way, but so what we're going to do with this program, and that's not the only way, but where we've got a very defined sequence like this pedestrian crossing, so we've normally got a green traffic light and a don't walk light turned on, but it's very defined. It goes amber on the traffic, green on the traffic, and then so on. It goes through a defined sequence until it comes to the end of green traffic again, and that's waiting for somebody to push the button. So the starting function is sitting there with a green traffic light on, a don't walk light on, and that's waiting for somebody to push the I wish to cross button. Yep. It's also worthwhile, if it is a sequence like this, to define that sequence in a chart and identify the state changes of the outputs in that sequence. So I'm going to go through the first couple of steps so you can see how doing that works. You need to look at this in your notes probably because it's a bit small on here. But the specification, I've pulled this from the full specification. On placing the PLC into run mode, M8002, you get a pulse on that as soon as you switch it into run mode. So you can use that to initialize your sequence and make it sit there and wait for the button to be pushed. So on PLC being put into run, the green traffic light and the red pedestrian don't walk light should be turned on. So what I've done here is I've got steps from 0, the initial state, up to step 6, and I'm already saying I'm going to assign M relays to each of those steps. That's me starting to make sure that I'm going to avoid double coiling, because I'm going to use the M relays to switch the actual outputs according to this sequence. Yep. And then I said that step in the program is started by going into run mode. So it's going to be started by M8002. You're going to turn on M0 as soon as you switch to run mode. And that's ended by the fact that M1 has come on. So you'll only ever have one of these M relays turned on at any one time in that sequence. And each of them is associated with some kind of change in the outputs. Yeah? The action. So when you turn on that step, start T1 10 seconds. So when somebody pushes the why have I put that in there? Look at I can't see the detail myself. That should say latch M0. Could just alter that on yours. Latch M0 and wait for X0. So what it's saying is turn on M0 and latch it and sit there and wait for somebody to push the push button. And then over here, what state is each of the outputs in when it's in that section? If you look at that, the green traffic light is on, the amber light is off, the red light is off, the wait light is off, the walk light is off, the don't walk light is on. So when M0 is on, we need to have the green light and the red don't walk light turned on. So somewhere in my program, what we're going to do is have this M8002, which is a pulse. I'm turning to run. That is going to turn on M1. So that'll do that. I've deliberately left a gap there for a minute. And that's going to latch. So I need to put a latch in. Sorry, M0, sorry. Put a latch in. That'll latch it. Right? And that's going to turn off when M1 comes on, when it moves to the next step. So every step will have an element that turns it on, and that'll have a different element that turns it off. And that's all already indicated in that chart if you complete it. So that does the first line of the sequence. Somewhere else in your program, you will have a line that says if M0 is on, turn on Y0, which is the green. Yeah. And you also have a line that says when M0 is on, turn on Y5, which is you don't walk.
Can you not have two outputs at the same time?
Yeah, you could do, but you're going to want to keep them separate, because when you come further down here, if you look at that, let's look at don't walk. It's on in the second step as well. So what am I going to do to make sure it comes on in the second step to the program I've already written? What am I going to do down here to this line? I want that's on in step 0, but it also needs to be on in step 1 as well, and step 2. So I'm going to, every time I want it on, every step I want on, I'm going to have an OR in there. If I put that in that line as well, if you look at Y0, it turns off there. Yeah? So in the M2 line, it doesn't come on. So you need a separate one for each output for this to work. Okay, and remember the amber light is definitely going to come on in 2 places in the program, and one of them is going to flash. Okay, the fact that the amber light flashes when it returns back the other way, I would definitely leave that right to the end. Implement that in your program right at the very end when you've got everything else working. Just leave it as a permanent on amber light both directions to start with. Okay, so then what we do, we've then written the code for the first step. So we put it in our PLC and we test it. When we switch it to run mode, does this turn on and do them 2 lights come on? Yep. Then what we got to do is say what happens with the next step of the program. The next step of the program is started by somebody pushing the X0 button. So, what we need, I've left the space for that there. That's programming the first step. So I did do this step by step. Look, I didn't. So there's the first. that's the first function. I've shown you how to program that, and there it is documented. PLC in run mode, not M1, output M0, which is step 0, and it latches. And there's my two outputs. Notice how I've separated here. I've got a section above that line that is my sequence section of program, and then a section below that, and I'll put a statement in saying that's the output section. And what I'm going to do is put all my outputs below that line and all my sequence one after the other in there. So I'm not just going to keep adding new bits of program on the bottom in a muddled fashion. I'm going to put it in a structured order, so if you're fault finding you can follow your way through it. It's going to step through that sequence as it goes through the time sequence of these traffic lights. When you switch it to run mode, that's what you should see happen. You won't see the pulse on that M8002, it's too quick. Remember, it only lasts one scan time, which is milliseconds. But you will see M1 come on, latch itself in, and these two lights come on if everything's working correctly. Alright? We then move on to the second line of the program. So I've included my first line here. We then need to write the second line of program, which is initiated by pushing the X0 button. What does it do? What is it ended by? M2 coming on, which is the follow-on step. Yep. So each step of the program is initiated either by a push button or the previous step, and ended by the next step being turned on. Because what's going to happen here is as soon as somebody pushes the X0 button, let's see what I've got on the next slide. I'm going to write it on the previous one, I think. So what we're going to do with our program for the next step, let's extend this down here, is the next step is going to be started by X0. Yep. It's going to be ended by the next step, which is M2. That's going to turn on M1, right? And M1 is going to latch itself in. What does that sequence do? It starts a timer for 10 seconds. So someone pushes that button, it's going to be 10 seconds before the next operation happens. So we need to put T1 K100, 10 seconds. So what it's going to do is turn that one on. The fact that it's turned M1 on means that this will open and turn that line off. Do you all get that? Yeah? So as soon as this one turns on, the previous one goes off. Okay? And then this M relay has got to leave the green light on, turn the wait light on, and also leave the don't walk light on. Yep. So in our output section, we'd have to add a line in there for M1 to turn on the wait light. We'd also have to put M1 in the board in the section for the green light and the don't walk light, so that those two stay on as well. And then put that program in, test that section, make sure that when you push that light, that timer starts and the wait light comes on. Yep. Then you can move on to the next section. The next section is started, so that's some more indication of that. So is that. Let's just go back to that big chart. Right up front. Where's it gone? So we dealt with this one, we dealt with that one. The next section is started by T1, ended by M3. It starts at T2 for a number of seconds, I can't read it, okay? And the state changes are that it turns the green light off, turns the amber light on, the red light stays as it is, the wait light stays on, the walk light stays off, the don't walk light stays on. So again, you'd put an M2 in a line for don't walk, you'd put an M2 in a line for wait, you'd add a new line for M2 to turn on the amber light, and you'd not put M2 in the green light, so the green light's going to go off as soon as it switched to M2. Do you kind of get the flavour of what's going on there? And in actual fact, in this program, just about every step is a copy of, apart from the first one, is a copy of the previous one with different element numbers. And the key to this is, can you work out what you need to do on the last step to make it go back and turn the first step back on again? And I'm going to leave that one with you until you maybe need some help in that direction. Because when it gets to step 6, the action at the end of it's got to be to go back to step 0, which is waiting for someone to push the button again. Okay? So that's where I'm going to leave you up here this week. I want you to have a go at the documentation, and then when you're ready, come and ask me, make a start on the pedestrian crossing program. Alright? Any questions?